Okay, so here's the exam question I gave you in class. So we look at this, and we can see it's to do with a time period. Indra works on reception in an office and deals with all the telephone calls that arrive. Calls arrive randomly, and in a 4-hour shift, there are on average 80 calls. So we know that this is going to be Poisson. So we're going to put our lambda as 80, and our time period is 4 hours. Right, now for A, it says using a suitable model, find the probability of more than 4 calls arriving in a particular 20-minute period. Well, if lambda is 80 for 4 hours, that means that lambda is 20 for 1 hour. And that means that lambda is 20 over 3 for 20 minutes. And that's basically what we're looking for. So that means that we are going to do calls, roughly distributed with a Poisson, and our lambda is 20 over 3. Okay, so we want the probability that there are more than 4 calls, which is the probability of 1 minus C less than or equal to 4, which is equal to 1 minus 0.205627, which means that it's equal to 0.79437. Okay, so now B. Indra is allowed 20 minutes of break time during her each 4-hour morning shift, which she can take in 5-minute periods. When she takes a break, a machine records details of any call in the office that Indra's missed. One morning, Indra took her break time in 4 periods of 5 minutes each. We're going to find the probability that in exactly 3 of those periods there were no calls. So let's call X will be the number of 5-minute periods with no calls. Okay, so then that means that X is roughly binomially distributed, and we're going to say that we're looking for 4 periods. Okay, that's our N, and the probability is going to be e to the power of minus 5 over 3. Right, now it's binomial because there's either a call or there's not a call. It's 4 because she takes 4 break periods, and it's e to the minus 5 over 3 because remember that with Poisson, the probability of the X being equal to any particular value is e to the minus lambda times lambda to the r over r factorial. So for this one, if basically we are looking for no calls, that means that r equals 0. So we've got e to the minus lambda, and then we've got lambda to the power of 0, which is just going to give us 1, and that's divided by 0 factorial, which again is going to give us 1, and that's how we get our e to the minus 5 over 3. Okay, so now all we've got to do is use our calculators, and for a PD, x equals 3 equals 0.0218625, or to 3 sig figs, 0.0219. Okay, so now on another occasion, Indra took 1 break of 5 minutes and 1 break of 15 minutes. Okay, so find the probability that Indra missed exactly 1 call in each of these 2 breaks. Right, so the probability that x equals 1 equals, well, for the basically for the 5-minute break, okay, for a 5-minute break, basically we have to use our, we've got to work out what our lambda is. So for 5 minutes, okay, that's going to be, we know for 1 hour it's 20. So that's going to be our 1 hour divided by how many 5-minute periods, which is 12. And that is going to be 5 over 3 for our 15-minute period. Lambda is going to be 20 over 4, which is 5. Okay, right, so we've got the probability that E equals 1. Okay, so for the 5-minute period, we're going to get the probability is equal to E to the minus 5 over 3 times 5 over 3. Again, because it's one call and it's E to the minus lambda times lambda to R, which is 1, over R factorial, which is 1 factorial, which is 1. And that's our 5-minute. And then for the 15-minute, we're going to get E to the minus 5 times 5. Again, E to the minus lambda times lambda to the power of R, which is 1, over 1 factorial. And this is the probability that she missed exactly one of each. So we're going to have to multiply those two together. And when we multiply those together, we get 0.01060502, or to 3 sig figs, 0.0106. And that's it.